Okay, welcome. Take 7. This pyramid image is of Giza, okay? And the shapes that you see on the screen drawn, hopefully you can see my mouse, uh, define basically the equivalent of a massive piece of shit falling from the sky, landing on the standard model, squishing that standard model so quickly to the point where it forms a shit crystal. That is what we're looking at, okay? Okay? So that's what we're looking at. So before I move on, you must understand everything you know is wrong, and until you watch this video and respect this video and its authoritar, you will always be wrong. Okay? Let us begin. First, the given. Energy is going into this corner, up this peak, down this seam, and out this way. Okay? At the same time that this is happening on this pyramid, it is happening on this bigger pyramid from the opposite side. Energy is coming in here, going out this way. When the energy of both of these pyramids reaches the edge of the pyramid, the very corner, right here and there, right? They will then shoot their energy across to the other corners. Because the mass, because of the corners, are directly connected. When they shoot their mass out, when they shoot their rope, all right, they collide somewhere in the middle. A nice color. Nice vibrant, annoying color. Orange. A nice, vibrant color. They collide here in the middle. And when these particles collide, okay, the path that they take changes. The particles are, so right, you got energy coming to here. The energy is released via kinetic energy, kind of like a Newton's cradle, right? Ball gets hit, ball gets hit, ball gets hit, ball gets hit, right? Same thing. At this corner, a ball gets hit, a ball gets hit, a ball gets hit, and those hitting balls are coming together until they get to the center point. When they collide at this center point, this distance between the two corners becomes very important, okay? At the point of collision, right? So if there's 2 points, 2 objects, the point of collision is like where the seams of the 2 objects meet. Okay? When that happens, the objects will shoot backwards. So if this is the point of collision right here, the object A from pyramid A will shoot directly back down the path it came from. It won't shoot this, so ready, it's this distance, but from the middle back its path. But when it backtracks, it does not go back up the seam of the pyramid. It goes into the base of the pyramid. Okay? When that happens, it happens in both directions, right? Goes to that point of the base of the pyramid, goes to this point of the base of this pyramid, which we'll notice is a different position in the grand scheme of pyramids, right? Because this backwards motion resulted from a collision, that is, vector A plus vector B, right? What we are looking at, because this is a collision on an angle, is an upward motion and a rightward motion being added to a downward motion and a leftward motion. Okay? So depending on how you want to look at it, it's a combination of these two. But because this pyramid is above each other these pyramids are above each other on the y-axis, it is the up and down directions that will end up colliding and being nullified to 0. meaning we collide here, and this backwards motion relative to the amount of space needed to travel. So light has traveled here, we need to travel between this space, relative speed of light. Because we only have this much space left to travel, we launch back into here, right? We launch half the speed of light into this pyramid, into the base. That's only one unit. That was just the inverted up and down movements, right? We still have an entire left and right movement to make, okay? And this entire left and right movement is completely unmolested, right? When we collided, we were going at this speed, like this full speed here, but at this collision, only our upward momentum is nullified, so we go back to here, right? And then we extend 3 full units, right? Doot, doot, doot. And when that happens, this is all a single 90-degree turn, right? This collides at a certain distance, which then has no choice but to go this way, okay? It's the only option. If you are keeping your flow going the same direction, you will go this many units, and you will turn. You will go this many units, and then you will turn. You will go this many units, and you will turn. It'll always be the same direction turn, right? If this is always taking a leftward 90-degree rotation to create, so we rotate 90 and go this way, rotate 90 and go this way, rotate 90 and go this way, the ending 90 will be the same as this 90, and then if you rotate again, it'll be here, rotate again, it'll be here. So what this does is it allows our particles to swap positions, right? The colliding particles will swap positions, and the one that was over here on the right hand side can now go through to this pyramid into the ground, and so they swap sides and then they continue on. But they don't necessarily continue on into the pyramid, right? They continue on this path defined by the Einstein and Maxwell fields, right? Which these fields are defined by an object being sent back and then launched forward much faster than it was sent back, right? We go back one unit. Well, we technically go back in diagonal 1 unit, and then we go that way. Well, technically nothing. It's this distance here. But nonetheless, this reaction creates these fields, field A and field B, which then creates a circle around the collision point, right? And this circle is the collection of the two collided energies. Okay? So when this collision happens, an energy field is released relative to field A and field B in the location of the collision, and this size of this shape is proportional to the distance traveled by these colliding particles, right? The circle is created by field A and field B, right? What is field A and field B? Field A is a shadow or a light. Field B is a shadow or a light. If field B is light, field A is a shadow. If field A is a shadow, field B is light, okay? When we have them in this orientation, this configuration, we are acknowledging that we are looking at an object within this circle. We are looking at an object that has both a reflection and a shadow and a physical location of its existence. And if you look at any real object, I'm sure we could find an example here, you will see these patterns, okay? Right? So how do I know that this is an actual truth? How do I know that these patterns actually exist because of these pyramids and for the reason that they do, right? Well, first of all, through recent discoveries of analyzing the ground, we can see that there is indeed perfect circles under these pyramids and around these pyramids. We see this for certain. And we also see rectangular shapes, such as what we might see right here from these connection of lines. And we also probably see something that kind of looks like this or that, you know. We see diamond shapes in this. Under the ground. Why do we see these shapes? Why are those shapes there? Those shapes are there because of this reaction here. The circle is from the collision and the movement resulting from that collision. And the further structures that extend beyond the pyramids are the result of the Einstein field and the Maxwell field being generated from the two particles. And okay, so it's like, this sounds beautiful, right? But how do we know for certain that this is true, right? Well, let's start with here. How do I know that energy is being pulled into this circle here, this corner here, right? How do I know? Look at the fucking sand, man. Look at the sand. It's going this way. There's a flow of sand going towards this corner. And if you look right here, you can see an even more dense flow. Right here. Right? And if we look over here, we can see a connection. It's like almost like little lightning bolts made of sand. Right? Little lightning bolts made of sand, which are connecting to here. And if we follow this path, which I don't believe is man-made, this path is the result of the existence of the pyramids. Okay? It makes a four-dimensional, hyperdimensional shape, right? And what's important about this right here, right? What do you notice about this? And this? It's a wave. What's most important about this wave? Well, this tiny pyramid. What do we notice about this pyramid? This pyramid is, right, if this big one is a cube, this medium one is a square. That means this one is a line or a dot. This is a hyper representation of this main pyramid, these pyramids, right? This is, if this is perfectly cubed, like the cube root of the area of this pyramid, then this one is perfectly squared, and this is perfectly one. Okay? What do we notice about this? Well, this dark side of the pyramid is bent in. It's bent in, right? It's not flat. It's bent. What's important about this, right? Well, it seems to align with the destruction of this pyramid perfectly, right? This arch connects. And what's important about this? Well, if we connect tip to tip, maybe we'll use a color that's not red, because I have red everywhere. If we go tip to tip, what do we see? We see that this tip's edge does not align with this edge, right? It's off. But what's not off is the segment that bends, right? This shadow is perfectly in tune with this edge of this pyramid. This shadow is also the same side that produces the Einstein field. As a result, we have gravity launching in this direction, right? And as we see it turn into its wave, the valley, the peak, the valley, peak, directly proportional to the location of the Einstein field, gives us a bending of space here, which destroys this small pyramid. But it makes it crumble. It's like it's a shard like this, right? A half circle. What do we know about this pyramid here? Well, that pyramid's more or less untouched. Maybe a little bit, right? Maybe a little bit because of the alignment. But that's more or less untouched right here. What do we know about this pyramid? This one Well, this pyramid, its point crosses over. Interesting. What about this edge? This edge is on the same side as, I would assume, the, right? If we go corner to corner, because that's what we somewhat did here, this aligns with that, right? This back edge, which aligns with the Maxwell side of things, right? And as a result, instead of seeing a bend in space type of cut, what do we see? We see like it's like you're getting hit with a bunch of sharp, pointy objects. You're getting stabbed. You're getting poked, right? You're getting poked and stabbed from this one. So what does that mean? It means while this one's getting pushed by a wave, this one's getting sucked in by a wave, right? Like this one's pulling data or something. It's just destroying in this shape. This one's a U. This one's a V, and this one's just a square, a circle, right? This is a pyramid, right? This pyramid was destroyed by gravity. This pyramid was destroyed by electromagnetism. And they maintain stability relatively through this center pyramid, which is an equivalent of a single unit. Now, as you can see, like, it's very complicated. Like, not only, like, you see this pattern here sucking in there, but mind you, it's also pulling an even greater amount of shit in this way, right? This building probably has some water problems or something. Probably has a lot of sand pulling into it. And then it just gets pulled into here. And then goes and does the process again. Right? That's this. And what this proves is P equals NP, right? This is how real this is, right? This is how valid this is, right? This is all evidence of P versus MP, right? Like I can look at this circle here, right? And I can tell you with absolute certainty very quickly that that circle is equal to this circle, right? I could say with absolute certainty that this circle equals that circle, right? Why? Because MC square. Because MC square. You can find like the shapes here in this ground are going to appear in this cloud, and the shapes in this cloud are going to appear in this ground. It's more than just a shadow, right? Like you can see the shadow, yes, but you can also see how that shadow impacts the ground, and vice versa. If you're on the ground looking up, you'll see how the ground looks at the shadow. With that, I leave you with one final thing. This area mass is the all-seeing eye right here, right? Circle, circle. And he's also a man from Egypt times, giving you a little wink, you know?